Hello everyone, my dear students. Again, your Vankara ma'am is here to conduct the video lecture on Unit 1 SCR. And today, in the last two video lectures, we have seen the Class A, then Class B, Class C. Now today we are going to see what is the Class D commutation. Okay, so this Class D commutation is also known as auxiliary commutation. Why it is known as auxiliary commutation? By drawing this circuit. So the circuit goes like this. So I will give the DC supply, because this circuit, all this class A, B, C, D, E comes under first commutation circuit, first commutation method. And in the first commutation method, it is applicable only for DC circuits, and we are giving this DC supply only, and this SCR is commutated firstly by means of the commutating component, inductor and capacitor. So here in this we are connecting an SCR. This is the first SCR. So we will name this as SCR TM. Then to this SCR we are connecting a resistance. Then again we will give back the DC supply. So this is a negative polaris VDC, fixed VDC voltage given to it. Now we are connecting a capacitor here. Upper plate is positive, lower is negative, capacitor C. And to this capacitor again we are connecting one more SCR. Okay, and again to this we are connecting a diode D, and to this diode D we are connecting an inductor L. Okay, so this is your TC or TA, where TA is the auxiliary SCR and TM is the main SCR. How the circuit goes? So the circuit goes like this. I will explain the circuit. So now in this auxiliary commutation method or Class D commutation method, an auxiliary SCR is required. It is essential to turn off the main SCR. The rating of this auxiliary SCR is lower as compared to the main SCR. Okay, so here just now explained you TM is the main SCR and PA is the auxiliary SCR. What is done actually? Initially when the DC voltage is applied, so the capacitor C will be charged up to voltage VDC with upper plate positive and the lower plate negative. As soon as this TM main SCR is turned on, the capacitor will start discharging through the main SCR inductive load L and D, that is diode. After C is completely discharged, what will happen? Its polarity will be reversed. The meaning of this is that the upper plate which was positive, it will become negative, and the lower plate which was negative, it will become positive. Since upper plate is negative, so immediately you can see a negative voltage is being applied to this main SCR. Okay, and as soon as a reverse voltage is applied across the main SCR, this main SCR, it will be turned off. Okay, and here the positive polarity is applied to this auxiliary SCR, so this TA will be turned on. Okay, so this in this process you can see only at a time only one SCR will remain in on state. Okay, so as soon as the moment the lower plate of capacitor has positive polarity, the auxiliary SCR will come in conducting mode, and as soon as the auxiliary SCR is triggered, the reverse polarity will be obtained across the main SCR. Okay, so here you can see in this method that the commutation is obtained by means of the reverse voltage which is applied across the main SCR. So this process is also known as voltage commutation process, because since the reverse voltage which is applied across the SCR plays an important role, so this class D commutation is also known as voltage commutation process or the auxiliary commutation method. This method is generally used in chopper circuits and inverter circuits. So this was all about the class D commutation. One thing which was left again as usual, as you all know, this diode D is connected in the circuit and is used in the circuit as the freewheeling diode, which is used to provide the low resistance path for the current stored due to the inductive load L. I hope you all have understood about this class D commutation. In the next video lecture, which we will see about the class E commutation, which is the last type of forced commutation method. Okay.